probably turn this off somehow. Not sure if I'm doing the right thing here. Here we go. One of the famous lines about AI is, how are we going to solve AI if we can't even figure out AV? I'm your post-dinner entertainment. I'll talk quickly and cover a variety of topics and then open it up for discussion. But I want to make one point very clear before I start, especially as I see folks like Steve Cross, who founded me at DARPA and the head of NSF and so on. No, you can't have the money back. But with that, let's get started on this journey. So as all of you know, I think we've all heard folks like Elon Musk warn that with AI, we're summoning the demon. But at the same time, we really need to separate science, the science of AI, from science fiction. We have AI scientists like the famous roboticist Rod Brooks, who says if you're worried about the Terminator, just keep the door closed. And now, in fact, those of you who are really up on your AI, Boston Dynamics, the company that was recently purchased by SoftBank from Google, actually figured this out. They've recently released a video where the robot finally figures out how to open the door, but there's still so many challenges, like going up the steps and so on. So I think we still have a long way to go with AI. So what I want to do today is make sure that we're all talking about the same thing and highlight some of the same issues. And I don't know if you can read this cartoon, but it says, you're not being replaced by a robot, a big concern for a lot of people. You're being replaced by someone who understands robots. So after today's talk, you will be replacement proof because you'll understand. Okay, so what is AI? What do we mean by the term? In theory, what we talk about is AI doing what humans do, sometimes referred to as artificial general intelligence or AGI. And that notion has given rise to a lot of Hollywood scripts, and you often hear when AI is used as a noun, like the AI is going to take over the world, they're referring to this kind of AI. Now, in practice, AI is very different, as illustrated by these pictures. AI is often very narrow tasks, like playing Go or speech recognition. They were once thought to exclusively be the province of humans, right? And now we find again and again that machines can do it just as well or maybe even better. So let's look at probably the most prominent case study, and that's Alphago, the program that beat Lisa Dahl, the human world champion. And a myth here, a lot of people felt like this is really now showing us the path towards full artificial general intelligence. And what I want to remind you of is that board games, both literally and figuratively, are black and white. They have discrete moves. They have these finite boards. There's a very clear win or lose evaluation function. And the amount of data you can have is essentially infinite, whether you get positions from previous games or whether the program plays against itself automatically millions of times. So in those sorts of situations, AI, the kind of practical AI, shines. And we see a lot of other of the major successes, whether it's chess or speech recognition, not speech understanding, mind you, but just the ability to recognize the phonemes of our speech, the way that Alexa or Siri does. We see facial recognition. We see some primitive machine translation, although if you saw Doug Hofstadter's article in The Atlantic recently, you know just how primitive the machine translation is. We've seen successes in Jeopardy and robotics. The point I want to make to you is that all these successes actually that look very disparate, right? Speech and robotics and so on, all come from the same pattern. And it's very simple. And this, by the way, is as technical as my talk gets tonight. I removed all of the equations, and right, people have had some wine, some dinner, so we're going to keep it very light. So, but here's the equation of AI. we take a set of categories, let's say B versus P, or in this case, cats and dogs. We take an enormous amount of labeled data, examples that are labeled by their category, is it a cat or a dog, what have you, and then we feed those to an algorithm, an AI algorithm, some software, and that produces the models that do the work for us. And the important thing to understand is all three of these components are created via manual labor, via people hard at work. So the point that I want to remind you of, if you take nothing else away from this talk, is that what's called machine learning is still 99% human work. Very, very much not a magical process. Nate Silver, whose work many of you know, in a somewhat different context, he said, figuring out how to optimize something, how to do this kind of machine learning, that's a computer science problem. But figuring out what to optimize, what to learn, is not. So let's remember that point, and remember that what we've created in all of these success stories are very, very narrow systems. I call them sometimes AI savants, right? They're incredibly good at one thing, and they do a terrible job even shifting from Go to chess, let alone from playing Go to crossing the street or something like that. The second really important point when we think about these narrow systems is to understand the distinction between intelligence on the one hand and autonomy on the other hand. Those are two very different things. And because people are both intelligent and autonomous, it's very easy for us to conflate these things. So I have here a 2x2 table to illustrate these points. You know, you can take the professor out of the university, but you can't take the 2x2 tables out of the professor. So here on the y-axis, as it were, we have degree of autonomy, high and low. Here on the x-axis, we have intelligence, low and high. And to illustrate that these are different, let's look at some of the cells. So when we have high autonomy and low intelligence, that's a bunch of teenagers drinking on a Saturday night. Okay, and in contrast, Alphago is a system, as I was saying, that has very high intelligence, but very low autonomy. It can't even play another game of Go unless somebody pushes a button, right? So these are very, very different things, and this is really an excuse to show my dad his grandson. But the point of this slide is that our kids, humans, are just so much more autonomous than any AI system. Let me just give one more example. We talk about self-driving cars, right? That sounds very autonomous, sounds scary. People love to talk about the trolley problem, right? Which way will the car go if it has to make a life and death decision? But remember that a self-driving car really isn't all that different than anti-lock brakes, right? It's a device that helps us get our job done, but it's not like a self-driving car chooses where to go. It's not like 100 of them are going to, drive down Northwest DC and try to take over the White House, right? Nothing could be further from the truth. Nevertheless, people ask me, given all the uncertainty about what AI can and cannot do, and some of the other issues that I'll talk about having to do with fairness, with jobs, and so on. And some people ask me, well, why don't we declare a moratorium on AI? Okay, what's the rush? Why don't we just slow down and study it carefully in a body like this one before we continue with AI? And I want to suggest to you two kinds of reasons why we really cannot afford to do that. The first one is that AI is global. So we have China declaring that they want to be the world leader in AI by 2030. We have Putin saying that he wants that the leader in artificial intelligence will, in some sense, own the world. So if we slow down, right, we'll be overtaken by other countries who are already racing and beating us in certain arenas. That's reason number one. But reason number two is that AI has tremendous potential benefits. I'll give two quick examples. The first obvious one is self-driving cars. We have on the order of 30 to 40,000 deaths on our highways each year, on the order of 1 million injuries every year. And a lot of those, the studies say that 80 to 90% of those could be prevented with this kind of technology. So that's one huge aspect. And Paul Allen founded the Allen Institute for AI with the mission of AI for the common good. So to explore these kinds of applications and to do the kind of basic research that will allow us to unleash the benefits of AI. We don't work on self-driving cars, but something that we do work on is building better scientific search engines. Today we have Google Scholar and PubMed and a few others, and they're quite comprehensive, but they're really not terribly intelligent. At the same time, the number of scientific publications is growing exponentially. There's a Moore's law of scientific publications, and we don't have any Renaissance men and women anymore, right? We need some way to cut through the clutter. We need the help of technology for scientists and medical researchers and ultimately doctors to do their job. And that's a project that we're working on. We have an engine called Semantic Scholar. It's available 24/7 at semanticscholar.org. And it's starting to scratch the surface here, to use AI to help you find what you're looking for. And really, in this sense, AI is less artificial intelligence and more augmented intelligence, right? The idea of this engine is to work shoulder to shoulder, if you will, with scientists to help do their job, and maybe even one day to go from machine reading to being able to suggest hypotheses and experiments to actual live scientists. So because of these types of considerations, my colleague Eric Horowitz, who's at Microsoft Research and former president of AAAI, likes to say, it's not AI that we ought to be worried about, it's the absence of AI technologies that's already killing people, right, on our roads, and also in hospitals where the third leading cause of death is medical error. And AI systems working alongside doctors and nurses could help prevent a lot of those errors. So there's just a tremendous potential here. Now, shifting to the worries that people have about AI, there certainly are concerns, and these go way back, right? So this is a picture of Isaac Asimov, who asked in the 40s and 50s, can we use AI, can we prevent AI from causing harm? And he suggested his famous 3 laws. And the problem with his laws, they were brilliant, but they were ambiguous, right? It wasn't clear how to operationalize them. And so what I've done in a recent piece in the New York Times is tried to suggest a more pragmatic framework for thinking about AI, saying things like, well, if we build AI systems, we really should have an off switch, okay? Let's be sure that we can turn the AI system off, or at least unplug it from the electricity just in case. Another really important point is, I think when we think about AI and regulation, we ought to be thinking about regulating the applications of AI. AI in cars, AI in toys, as opposed to the field itself, right? The field of AI research is amorphous. Where does computer science and software leave off, and where does AI begin? That's actually very difficult to determine. So rather than try to regulate the science, let's look at particular applications of particular regulatory bodies and think about what we ought to be doing there. And so a few ideas that I suggested. One is that we should realize that people are ultimately responsible when AI systems are in use. So the notion of, my AI did it is not an appropriate excuse, right? If my car runs over your dog and I say, I'm terribly sorry, it was a self-driving car, That's not right. Either you're at fault as the driver or the manufacturer is at fault if the technology is faulty, but AI is a set of tools, and we need to make sure that the responsibility rests with the people using these tools. Another really important point is that we need to have full disclosure about AI. So there's all this talk, right, about the bots, during the election and even now, and yet we don't have AI systems labeled, right? We have Intel inside when it's made by Intel, but we don't have intelligence inside when it's an automated system, and people really need to know for the obvious reasons. And remember about people a lot more naive than yourself who can easily be confused. Am I talking to a person or am I talking to an AI system? I think that's an important distinction. The third principle that I talked about is one of privacy. Privacy is obviously a major concern in many issues. AI exacerbates that. Think about AI Barbie. We have these dolls that have chips in them, and they interact with our kids quite extensively. It's very easy for them to elicit information from our children and then upload that to the cloud. And if any of you think that's unrealistic, the picture there is of the Roomba, right, the robot that cleans your house. And it was reported in the New York Times that the executives of Roomba were seriously considering selling maps of your house, automatically created by the Roomba as it's navigating around, to third parties, right, who could use it to figure out, I don't know, if you need new carpets or what have you. So AI creates enormous opportunities for privacy violations, and we need to think about that very carefully. The last point I want to make, and this wasn't in the New York Times article due to lack of space, but I think it's an extremely important point, is to think about the potential of AI systems for increasing bias in society. Remember that all these systems are based on training data, right? And training data, by definition, comes from the past. The models that are created are then used to make future predictions. So what these systems are all doing is using the past, right, to generate models that predict the future. In the process of that, if our past was racist, was sexist, was inappropriate in other ways, the models will not only potentially carry that over into the future, but they actually, for technical reasons, they can exacerbate that. If there was a 20% bias in the data against some group, once the modeling exercise is finished, it could be 40 or 60%. So, and we do have technical ways to prevent that. So whatever we think about the training data, I tried to formulate the principle that AI should not amplify the bias in its data. It should not make the problem even worse. So one of the trickiest issues is the one about jobs, and I'm actually almost done here. I'm kind of doing a survey of the different topics, and then we'll open it up. And I like to point out that one of the reasons that I'm not a big fan of the warnings about superintelligence and AI taking over the world is because I think it's a distraction from the real issues. One's about bias, or certainly one's about jobs, right? We have a long-term trend of automation and software and robots taking over jobs. And Amazon opened their fully automated store in Seattle recently. Retail jobs are at stake. Obviously, transportation jobs are at stake, particularly for truck drivers and so on. So what are we going to do about AI's impact on jobs? Some people like Mark Andreessen or Hal Varian, who's the chief economist at Google, say, don't worry about it. New jobs will emerge as they have in the past. I'm not sure that's completely satisfactory because there can be a lot of anguish and displacement while that process takes place. And some people argue that this job loss is accelerating. We don't necessarily know. In Silicon Valley, the notion of a universal basic income, right, giving some money to everyone is quite popular. My problem with that notion is that we're struggling to have universal health care in this country, right? So how are we going to have universal basic income? That's a challenge. I also have colleagues like my colleague Daniela Roos at MIT who says what we need is technical training. And I do think that all of us, and certainly our kids and grandkids, need more exposure and understanding of programming and of AI, and there's wonderful bodies like that. But again, it's not realistic that we're going to take coal miners and turn them to data miners, right, by and large. It's not realistic that people who did not finish high school, and we have plenty of those in this country, are going to become crack programmers. So we have a real problem here. And the suggestion that I made, which again is far from a panacea or a comprehensive solution, but I do want to say that we ought to think about caregiving as an option for displaced workers. And by caregiving, I mean the whole range from companions to elder care, even food delivery. My teenager was working this summer delivering food to people for whom that might have been their only human contact or one of their only points of contact during the week. What if we allowed people like that to spend an extra 15 minutes and have a cup of coffee with that elderly person? What if we supported that? That might be more palatable because it's a job, it's a service, rather than just universal basic income. And the thing that's really important is to realize that this is a uniquely human job, right? Again, some of my colleagues are very excited about having robots take care of the elderly. And again, in Japan, the demographics are such that there might not be a choice. But wouldn't you rather have a human be in touch with whoever has those needs? I think we do. I think humans are uniquely qualified. And that's something we ought to think more about. And actually, it's quite common in other countries. I grew up in Israel, and there it's very often the case that you see an older person and they'll have a human companion, gasp, and it's a win-win. So this is where I want to end on these kinds of questions. We understand what AI is, hopefully a little bit better now. We have these questions: should we be engaged in AI? Should we slow it down? Should we speed it up? And the point I want to leave you with is that AI is a tool. It's a technology. It's not some mysterious magical entity. And so ultimately, the choice about how we use AI, what role it has in our society, is ours. Thank you very much.
Thanks very much for a very nice talk. So what are going to science and engineering? What excites you most about challenges in AI, and what kinds of science and engineering problems are your folks at the Institute working on?
We're looking at a lot of work on natural language processing. So again, if you think about language, which we use all the time to communicate with each other, but also hopefully with AI systems, that's the opposite of what happens in a board game, right? It's not cut and dried. It's full of nuance. It actually requires common sense often to understand even a simple sentence. And so we're doing a lot of work, a lot of basic research to understand language, and of course NSF funds a lot of research by others along those lines. And we feel that if computers could understand language, it would open up a lot of these possibilities, like better scientific search engine and many others as well.
Thanks very much. Great talk. Thank you for your time. I'm Tim Persons. I'm with the Government Accountability Office, or GAO. We're about to push out a study actually on this strategically for the Congress in just a few weeks. But one of the things that I think is so profound about this is the change from what I think of as deterministic computing into probabilistic. and the idea of how will we be able to even get over that sort of context of what that means about training. Would we get in a car where you would say, well, with some high probability we can get you from point A to point B, that kind of thing. And I'm particularly concerned about, as we evaluate the regulatory space, how a regulator, I think as you rightly said, is going to focus on, or ought to focus on the application versus just the general technology itself, whether you're SEC or whether you're the NHTSA, the National Highway Transportation Safety Administration, or whatever. So I think that's such a profound thing. I was wondering whether you're seeing the same thing, or do you think I'm overstating that, or I'm overly worried? And don't be so worried about it. Thank you.
So it is a very rich topic. Let me make two points. One is it's entirely possible to have a stochastic or probabilistic system, but still have a deterministic outcome, right? Remember what underlines Newtonian mechanics, and the chair that you're sitting on is quantum mechanics, right? So I wouldn't extrapolate from the kind of programming we talk about to the notion that we can't draw very specific and reliable conclusions. I do think that there are things to be worried about. We ought to think a lot about how we regulate cars, and in fact, there's a patchwork of regulations emerging from municipalities and states, and that's really problematic. This is a great time for the federal government to step in and figure out nationwide regulations. But the other point that I really think is important to mention when we worry about the technology is, the old joke, there was the old joke, how's your spouse, to make the non-sexist version, how's your spouse compared to what? So the point is, when we evaluate the technology, we can't evaluate it relative to the ideal transportation vehicle. We need to evaluate it relative to human drivers who are texting and driving, drinking and driving, and killing us every day. So I'm very confident that in a small number of years, we will have driving technology that's safer. And that's what I'm really excited about.
Leo Chalupa from George Washington University. So you mentioned the competitors China and Russia, and in recent weeks there have been a number of articles in the Times, Wall Street Journal, the Post about the tremendous amount of investment China is making in AI, bringing people back from the States as they're in areas. What's your assessment in terms of the basic science, not the application, but the basic science of AI, China, and let's say Russia compared to us today?
That's a great question, and we actually have statistics from the various AI conferences. So people are fascinated by this, and the top basic AI, the dissemination of results in AI is via conferences like AAAI and NIPS and so on. And the number of papers being submitted and accepted by Chinese authors is rising rapidly. And I think that it's still the case that we're in the lead, but I think that could easily change. And I think a lot of it actually has to do with immigration, right? So where we've been successful, and if you look at my institute, where I'm very proud of the people we have, it's the United Nations, right? We have Vietnamese, Egyptians, Israelis, Koreans, Indians. We even have a few, Americans, sprinkled here and there. But the point is that that's the situation. We have actually several super sharp Iranian scholars, and they've had all kinds of problems. A lot of these people, not just the Iranian ones. So if we screw up, to use the technical term, our immigration system, then we're toast.
So John Zolber from Raytheon, fascinating talk. I think you made a great point in the beginning, talking about AI savants. I like that term, right? So I would like to hear your thoughts on scientists and engineers talking about what AI is not. You actually did, but I think as a community, that's really important. So when Elon Musk talks about AI, all the negatives, right? So your point about AI savants, that AI isn't actually all these global things, how we as a science community, engineering community, should not just chasing money from funding agencies and things like that, talk about what it isn't and what the limitations are. What are your thoughts on that?
I think you're absolutely right. And that's why I tried to distinguish between the two different kinds of AI. I sometimes use the metaphor that, remember in the old days we had these stereos, right? And you would adjust all the knobs and dials to get the sound just right. Well, machine learning, deep learning, right, this fancy stuff, is a lot like automating the adjustment of these knobs. But it's not the case that you automatically adjust the knobs on the stereo and the stereo will suddenly turn into a Death Star. It's just, it's unrealistic. And so we do need more people making those points. Thank you.
Hi, Katie Stebbins, University of Massachusetts. My question's around artificial intelligence as maybe a lift or an augmentation for folks who may not have the skills to fulfill certain jobs, but is there an opportunity to look at AI as a way to on-the-job train or to increase productivity of someone who may not have the skills to do the job otherwise? And I just love your thoughts on how we might use it as a augmented learning tool for productivity.
I think there is that opportunity, and that's a fantastic way to think. I think we do have a lot of challenges, right, communicating with the programs. That's one of the reasons, I hope we can make progress on natural language processing. At the same time, while I very much sympathize with what you're saying, and that's what we're looking for, I also don't want to paint it as too rosy a picture, right? The reality is that right, often the AI systems will rapidly take away the jobs. And if we look at Amazon, for example, right, at the Amazon warehouses, the number of people in those warehouses has been dropping sharply. And some of the last tasks, turns out that the human hand is a remarkable tool. So picking items and counting items are some of the last things left. But these things are going to go away. So the reality is that as much as we want to use AI in the way you describe it, and we will, it's also the case that it's going to take away jobs.
Jack Winstrand, Agilent Technologies. You're working on AI in the service of the human condition. We have huge challenges in healthcare. If you take a 10-year horizon, what area do you think has the greatest opportunity for AI to revolutionize healthcare?
Wow. You probably know the answer to that better than me, but let me just suggest a few places where I see huge opportunity. One's I mentioned in terms of research. So Semantic Scholar already covers all of biomedicine, and I think we can help those scientists be a lot better at their jobs. It's also the case that when I talk to my friends who are doctors, they often complain about the amount of time they spend in dictations, the amount of time they spend in compliance, right? And a lot of those things can be automated, right? People are working on Siri for the doctor's office, so the doctor doesn't have to keep typing. Maybe he or she could even look at you while you're talking. Let Siri take care of that. The gentleman here from Google Brain is working on using AI on top of electronic health records, right? There's so much information there that we're not able to mine. But really, to me personally, one of the biggest things is I'm terrified of going to hospitals, right? They're opaque, bad things happen to people. Then again, that's documented. That's not my paranoia. The statistic I gave is from I forget the name of the journal, but from a medical journal, right, about the third leading cause of death. Well, AI systems looking over the shoulder of a doctor and making suggestions or sounding alerts when a mistake is made, this is not pie in the sky, okay? This is something that we could do today and do it with increasing efficacy. And I wish we would before my next hospital visit. Thank you.
Robbie Sponcheroy with Lockheed Martin. Going back to your chart of the autonomy and intelligence, and thinking about a government, like a regulatory framework to develop trust in a system like that. So I see there's really sort of two schools of thought. There's the experimental versus the theoretical. The theoretical folks are trying to come up with frameworks, formal verification, metrics and approaches. And then the experimental crowd is like, let's just operate the system for, N millions of miles or hours, what have you. From your perspective, how do you see these two camps, will they emerge at some point? Is one camp winning versus the other? What are your perspectives on that approach to basically verifying and validating trust in a system like that?
Yeah, I do have a very strong point of view about that, unlike all my other points of view, which were. But I did my PhD at Carnegie Mellon, where Newell and Simon talked about computer science as an empirical inquiry. So I'm very much an experimental computer scientist. I don't believe that we're going to be able to prove theorems about these systems. The analogy I would give you is, what's more complicated, the system that flies an aircraft, the system that operates a human, or Windows? Right? Those are very, very complex systems. How many theorems have been proven about Windows in the last decades? The answer is 0, right? These systems are too complex to model mathematically. And I do think that the people who attempt to create very mathematical models of AI are going to be always relegated to a very, very theoretical realm. We can adopt engineering practices to very carefully test systems and simulate them and retest them and look for various edge cases to improve their safety, and we can build redundancy. There are many methods that we use as engineers to help with safety, but I think that the experimentalists and the empiricists are the ones that really are showing us the right way here.
Hi, Janet Nelson, University of Idaho. I appreciate your quadrant analysis too. I'd like to push a little bit more on your views of the distinction in AI between being an execution mechanism for distinguished tasks, even if they're very complex decisions and very critical decisions, versus AI as a generator of new knowledge.
So I think that we would love to see AI as a generator of new knowledge. I think we've seen relatively little of that. What we do see, though, which again is exciting if used properly, is we see narrow arenas. You mentioned in medicine, there are often situations in radiology, in dermatology, right, where we have a lot of background, a lot of historical diagnostic decisions, and we can train up a model based on those and then do a better job at making those diagnostic decisions than doctors do, who get tired, who get distracted, who make mistakes. And of course, when you put the systems together, a human and a machine doing the diagnosis, it gets even better. So I don't know if you would call that new knowledge per se. Yeah, it's on the border, but that's what I see in the next, let's say, 5 to 10 years, is more and more of these systems that help us, say, make these diagnostic decisions much, much better.
Hi, Kelly Sullivan, Pacific Northwest National Laboratory. A little bit of a follow-up on that as a quantum chemist. So I'm very much in the fundamental generation of new knowledge field, or at least I was when I was not management. It happens to the best of us. But I'm wondering, because as an active research scientist, one of the skills that I had was making the nonlinear connection between data and analysis and making that leap to an assumption about something about the physical world that data was telling me. And then my colleagues would say, what? And then I would have to explain how I felt that connected thing meant. Reality was the way I thought it was described. AI, I think, can do that. I think it can get there and take this deep learning thing and say, here's this massive amount of data that you've generated, and here's the leap. But what it doesn't have is the human who can explain how the leap was made and convince the other humans why the leap is real. And so how are you going to get it to the human scientist, the really fundamental, this is why that atom did that thing person, not the diagnostic person. That's way down the field for me, but I'm talking about the really fundamental scientist. How are you going to help them believe the AI analysis is correct when it's a nonlinear leap from where they've come from? Does that make sense?
It does make sense, and you're absolutely right. So I didn't have a chance to get into it, but one of the biggest weaknesses of these systems, these deep learning systems in particular, is explaining how they made their decision, right? So it's a statistical model, and it'll make a prediction. And let's talk about it in the context of diagnosis, right? I imagine the situation sometime in the future where I go and have a series of tests run, and they say, Professor Etzioni, we need to remove your kidney. And I'm like, wait a minute, I'm attached to it. It says, sorry, the statistics show it's got to go. We're wheeling you into surgery right now. And that's obviously a terrifying thought. And so a lot of people are working on more explainable, more transparent AI systems. But one of my colleagues, Pedro Domingos at the University of Washington, makes an interesting counterpoint. He says, what would you rather have? A doctor who's 80% right, but can hold your hand and explain to you what's going on, or a doctor who's right 95% of the time, but perhaps is less articulate? Now, a little bit of a false dichotomy, but still something to think about, okay? So the scary thing about these inarticulated systems is that they are better at making those diagnoses than the doctors. Now, in the case of science, right, it's going to be a long time before the AI systems can make these amazing leaps that scientists make. But we will face soon a situation where do we go with the statistical model or do we go with what the human doctor says? When they agree, life is great, right? They're both saying the same thing and the doctor can explain why, never mind if their explanation is actually maybe inaccurate, it's reassuring. But what when they disagree? Who are you going to listen to?
Hi, Wayne Johnson from McGuire Associates, but I'm going to be speaking from my Hewlett-Packard background. About 9 months ago, I met a colleague who came to Boston, and we were talking about China, where I helped set up some operations there. And he said, did you know that, I think it was Foxconn, put 50,000 robots in one of their manufacturing places? Which I said, of course not, I never heard of it. And I checked the New York Times, and sure enough. What do you conclude? To me, that's an amazing number. And I thought they were there because they were low cost, and now they put 50,000 robots doing something. What are your comments about what I just said? Does that make sense? Where's that going? Why is China doing that?
So manufacturing is becoming increasingly automated in China as well, and I did hear about that story. I don't know the particulars, but I think it's again a huge challenge, and manufacturing is going to be increasingly automated. The one advantage that people have is when you need to change the production line very quickly, right? People have an easier time adapting, but even there. That's changing very rapidly. So you're speaking the truth. Good or not is remains to be seen. Yeah.
Hi, I'm Mehmet Kayal from NIH. Thank you for the nice talk. There were some questions about the proof of whether something is really done in AI or not. And when I give lectures to my students here and there, and I always ask the question, what is an AI question? What is an AI problem? And what is an AI heart? And people sometimes came with the answer that it is it's a humanly done, doable things, then it is probably AI problem. But we have to distinguish between AI techniques and AI problem, I say. So I would like to ask your opinion, what do you think about this? When I say an AI hard problem is a problem of which best solution is not available in a tractable amount of time, tractable in a reasonable amount of time. With the other tools and methods, like if you can find the best solution, which we call it global maximum, in a reasonable amount of time with a mathematical method, then it's a mathematical problem, it's not an AI problem. But if you are, settle down with the solution that is good enough, not the global maximum, but somewhere good and sufficient, then it's an AI problem. What do you think?
Well, let me make kind of points on both sides of that, again, very rich question that you raised. On the one hand, when we talk about deep learning or neural networks, right, to use the older term, it kind of connotes, the brain and humans and so on. But if you look under the hood in those systems, they're doing matrix multiplication, right? They're taking derivatives in an n-dimensional vector space. So I do think that a lot of what goes by the name of AI is statistics, is very, very mathematical. It doesn't feel intelligent in any way, shape, or form. So that's just a fact. On the other hand, right, if you look under the hood here, right, as you well know from NIH, it doesn't look very human intelligent either, right? There isn't a homunculus, a little person kind of figuring things out, right? We have, ion potentials and, hormone diffusion and electrical impulses and all that stuff. So, what is AI in a more philosophical level is hard to say. I do want to add, though, one more perspective on this, which is I think I'm more or less quoting verbatim Pablo Picasso, who said, computers are useless. They only answer questions, right? We need to ask questions.
I'm Brian Wright from George Washington University. So putting your professor hat on, so how do we prepare students for this AI future? And are there things we can be doing, I guess, academically to not only prepare them for the use of these AI tools, but also to meet the demand that may be coming out of, the AI industry?
Right. So I think that the first step is really in elementary school. And I think it's really upsetting to me the limited degree of sophistication most children at the age of 8, certainly by the age of 10, can program. And there's incredibly wonderful games and things that make it fun. And it's really disappointing to me how slowly we've adopted that in our elementary school curricula. And it has to do with the fact that a lot of the teachers, I was a big advocate in my son's school, which was, a private school and had all these resources. I was a big advocate for, in their what they called their tech class, instead of learning features of PowerPoint, that they actually learned to program, until I realized that the teacher didn't know how to program, and what I was really advocating was firing her, which I didn't feel good about. And again, maybe we could have reached something if she'd done some additional training, but the bottom line is she didn't know how to program, and she wasn't going to teach the kids how to program, and I had to give up. So we really need to start at elementary school and move through that. When I was in college, there was a basic programming requirement. This is in the 80s. A lot of schools have taken that out, so you can graduate from college without being able to write a really simple program, with a loop and so on. That's very, very problematic. So I think people need to know that. It's not because they're all going to become programmers, because then it demystifies things. Then you know what the machine can and cannot do. So that's one huge thing. But the second thing, the place where the computers are least good at, and they're going to be least good at it for the longest time, is around teamwork, collaboration, empathy, a lot of these human skills. So I would also emphasize classes where they encourage and build those abilities more. For example, as a computer scientist, we had a big emphasis at the University of Washington on group software projects, because writing software is no longer a solitary thing where you sit in your cubicle or your garage or whatever and write the software. It's very much of a group effort. And it's not just a group effort with programmers working together. They're working with designers, with ethnographers, other things like that. So I think there's huge opportunities to double down on what we're uniquely good at.
Hi, Avery Sen. I'm at Toffler Associates. I don't want to anthropomorphize here too much, but I wonder if there is the equivalent, the analogy to mental health for artificial intelligence, something that's along the lines of healthy cognitive functioning. So I don't know if there is such a thing, and if there is, I'd like you to tell me that there is, and if there is your institute studying it?
That one I can give a short answer to, so we'll have time for one more question. Not yet.
Well, thank you again, Oren. Don't go anywhere, but let's thank Oren Etzioni one more time for a fantastic. Great start to our program. We have a little gift for you for joining